So now we're going to take a look at some examples where the graph is provided and you have to find the equation that they use to shift or translate or reflect the graph. Now the good news is they are always going to give you the logarithmic function that they are translating or transforming. And the reason is otherwise you won't know what your base points are. So the first thing we do, honestly, is you look for this asymptote change. It's supposed to be at 0, and in this problem they moved it to 1, right? So that means that h has to be 1. Pretty easy. It's going forward 1. So when I put in the equation, I'm going to use a minus, but on the graph, it's a positive number opposite h. And the next most important point, by far, right, is from the original logarithmic graph, you know that there's an intercept at 1. So try to use that and see if that will do it. Now, if you move this forward 1, you can see that you don't have a crosshair. But then you look for the crosshair. There's one right there, just like right above it, there's a crosshair. So that tells me again that h is 1, but now I can see that k is also 1. So try not to overcomplicate it. Worry about the asymptote and the intercept because those are consistent for all logarithmic graphs. So I come down here and I realize, okay, well, they're talking in here about f of x equaling log base 2. And yeah, there are other points like 2, 1, and 1/2, -1. But if I have the answer now, I don't need those other points unless something goes wrong. I need additional information. So this is f of x is equal to log base 2. Open a parenthesis so you can put your h in there. You have an x. So h is 1. So in here it'll be -1, remember opposite h. And k is 1, so +1. And that's that graph, but now translate it. So what happens if you have a base 10 graph? I mean, this graph doesn't even seem to fit the graph, but that's okay because I don't really need the 10, 1 point. I just need the intercept. Start with your asymptote. It's at -1, right? So you can clearly see h is -1, which means it goes to the left, okay? And then I'm going to start with my intercept, right? My x-intercept for all logarithmic graphs is 1, 0. And clearly it's not there. So let's start with moving that intercept back 1. So if I move it back 1, okay, cool, I'm now here. And then look for a crosshair. There it is, right there. So that point is where I've shifted this original point to. So that's telling me again, h is -1, which I got from the asymptote first. But now I know that k is -2. So I come over here and I write f of x is equal to log, open a parentheses, put an x there. Here I'm going to have h is -1, so opposite here, +1, k is -2, k is exactly what you have. So even when you get something that's an ln, nothing is going to really change. Look at the asymptote. Always start with the asymptote because it is obvious and cannot really be altered based on what you're seeing. So h, right, is going to be 0. That means I would close my parentheses off. And my intercept should be at 1, 0, but it's not there. Oh my goodness, they also reflected it over the x-axis, right? So we got to just stop for a minute and try to think through this. The x-axis reflection is caused by a being 1. Remember the alphabetical order. A would be x-axis, B would be y-axis, which I don't see. And this is an anchor point. So it's actually kind of dangerous to try to use the other points because, you know, this one would have one at 2.71. There would be a dot here, and then we would reflect it over the x-axis, so it would end up being here. And then that actually might mislead us because that's confusing in the fact that I have that translation. But if I use this anchor point at the x-intercept, all I have to worry about is the fact that h did not move. Let's find a crosshair right here at -3. So that means that k is -3, and I don't have to worry about the reflecting over the axis to find the k value. That's very convenient to understand. Now, if that doesn't do it, you might have to move to the other point. But if you don't need that other point, why would you use it? So not having an h means that I close off my parentheses for the x. I have a negative in front of the ln to reflect over the x-axis. And then I also translated the graph down 3 units. So just a nice review of transformations, this time using logarithms that have different base points. And that's why it's so important to really focus on that x-intercept and see what's going on there. And again, I mean, if you really want to use another point, I mean, we can talk about it. Like in this problem, it would have been 2, 1. It would have been here. You can already see how that's already kind of confusing because it's moving around. And if I move forward 1 and up 1, I have an additional crosshair, but that doesn't really help me learn anything that I didn't get by just worrying about the x-intercept and the asymptote. Asymptote first, x-intercept second. If you do that in the other order, it doesn't work. So again, asymptote first, x-intercept second.